In this video, let's take a look at log transformations. So we're looking for what transformation occurred between the parent function and the following 6 examples. So in number 1, we have a negative out front and we have a 3 out front. So the negative makes it reflect over the x-axis. Let me write that a little better. Reflect over the x-axis, and then the 3 makes it have a vertical stretch or expansion. They mean the same thing. I'm going to say vertical expansion by a factor of 3. Number 2 has a 0.65 in the front, and then we have a -2 back here in this grouping symbol. So the 0.65 makes it have a vertical shrink or compression by a factor of 0.65. So I'm going to put vertical compression by a factor of 0.65. And then the 2 being subtracted and in the grouping symbol makes it go to the right 2 units. In example 3, we have -9, again in that grouping symbol, makes it go to the right 9, and then the +2 is not in a grouping symbol, makes it shift up 2. In example 4, we have a couple of things going on. We have a negative in the front, that makes it reflect over the x-axis. We have 1/100, which makes it have a vertical shrink or compression. So this time I'm going to write shrink, vertical shrink, by a factor of 1/100. The negative on the inside of the function in front of the x makes it reflect over the y-axis. And then last but not least, the +11 being in parentheses right there makes it shift to the left 11. In example 5, we have a pi out front. Pi is about 3.14, so it would vertically stretch or expand. So let's put stretch this time since we've written expansion already. So it's a vertical stretch by a factor of pi. Then the -389 out back here makes it shift down 389. And then last but not least, we just have log base 2 of x -7. This would make it shift to the right 7 units. Notice when I'm picking out transformations that I'm not concerned about the little base number. You only look at all the other numbers going on with your function.